In this walkthrough, we're going to use Kong Gateway to manage port forwarding and load balancing across two Minecraft servers. We want multiple game clients on our network to hit an endpoint which Kong listens to, and then Kong will distribute those connection requests across our two servers. To do this, we're going to start simple and then iterate, adding complexity with each iteration. We'll start by spinning up a single local Minecraft server without any port forwarding. After that, we'll spin up a Minecraft server on a non-default port, configuring Kong Gateway to port forward connection requests to that server. And for our last step, we'll spin up two Minecraft servers on different ports, configuring Kong Gateway to load balance and port forward connection requests across those two servers. Before we get started, let's go over some of the things you'll need on your local machine in order to walk through this project with us. You will need to have Docker Engine installed on your local machine. The Minecraft server runs within a Docker container, so you will need the ability to run Docker containers. Next, you will need to install Kong Gateway. The installation steps vary depending on your environment and setup. When we get further into the walkthrough, we'll cover startup and configuration. Lastly, in order to test that you've deployed your service successfully, you will need to install the Minecraft game client and log in as a paid owner of the game. The free trial of Minecraft doesn't allow for connecting to multiplayer servers, which is what we'll be running. In our first step, we're going to run a Docker container with a Minecraft server image running, which is available at Docker Hub. We'll do this all from within a terminal window. The command we're going to run is docker run -p, and then the port 25,000:25565. We're going to bind our host's port 25,000, that is port 25,000 on your local machine, to the container's port 25565, which is the standard port that a Minecraft server runs on. Then we're going to add an environment variable for our Docker container. That's a -e with EULA, all caps, equal true. This indicates that we accept the usage agreement for the server. And then we include the name of the Docker image that we'll be running, which is itzg/Minecraft server. We run that command, and we'll see that it pulls down the image and starts up the server. This is going to take a little under a minute to spawn an entire Minecraft world. While that's running, we'll go ahead and open our Minecraft launcher, which you should have downloaded through the Minecraft website, and we're going to click on play. This launches the actual Minecraft game client on our machine, which will also take a few moments to start up. Let's check back in at our terminal window where we're spinning up our Minecraft server, and we can see that it is done and listening. Now that our game client has started up, we'll click on multiplayer, and then we can click on direct connection to put in the server address that we want to connect to. From our Docker command, you'll recall that our server should be available on port 25,000, so we enter localhost 25,000, and we click on join server. After a few moments, we're in. Back in the terminal where we were running the Docker container with our server, you'll see the log message that says that a new user has joined the game. If in our game client we disconnect from the game, we see that log message here. Great, we have our simplest setup working, a single server and a successful game client connection. Let's stop our server and move on to the next step. Assuming that you've installed Kong Gateway to your system, you'll now need to set up your initial configuration file. In /etc/Kong, you'll see a template file called kong.conf.default. Copy this file and rename it to kong.conf. Next, we'll open kong.conf to make a few edits. There are only 3 places in the file that we need to edit. At around line 368, we need to uncomment the line for stream listen and set Kong to listen for TCP streaming at 127.0.0.1, that's the localhost IP address, port 20,000. This is the port on localhost where we will have game clients try to make a connection to the server. Next, at line 922, uncomment that line and set database to off. We'll be using the database list declarative configuration for Kong. And lastly, at line 1106, we need to set the location of our declarative configuration file. This is the file that will have all of the configurations for port forwarding and load balancing. This is a single YAML file. Set the value to the absolute path to the project folder we'll be working in to a file called kong-minecraft.yml. We're going to write this file shortly. That's it. Save the file and exit. Before we can start up Kong, let's go to our home folder, create a project subfolder, and then create a file called kong-minecraft.yml. This will be our declarative configuration file that Kong looks to when it starts up. Open this file for editing. Remember, for this step, we simply want Kong to do a simple port forwarding to a single Minecraft server. We put in the format version for this declarative configuration syntax. In this file, we declare a new service entity, which we'll call Minecraft Server A. This service uses TCP, and it will be found at localhost port 25,000. That's how we configure our Docker container. Next, we define a route for the service, which associates our service with a URL path or an incoming connection destination that Kong will listen for. We provide a name for that route, telling Kong to listen for requests using TCP or TLS on the destination that we specified in our kong.conf file for stream listening. That's the IP address for localhost 127.0.0.1 and port 20,000. And that's our entire declarative configuration file. Go ahead and save that file and exit. Next, we start up our single Minecraft server as a Docker container. Just like in the previous step, we bind our host's port 25,000 to the container's port 25,565. We'll let that spin up. And while that server is spinning up, in a separate terminal window, we'll start up Kong. Back in our game client, we should now be able to join the server at localhost 20,000. Remember, this isn't actually the Minecraft server port. It's the port that Kong is listening on for TCP traffic. We make a request to join the server at port 20,000, and Kong forwards that traffic to our actual Minecraft server at port 25,000. We click on Join Server, and we're in. Great. Now, for the final step in our walkthrough, we're going to spin up two Minecraft servers and use Kong to load balance connections between the two. Go ahead and disconnect in your game client and stop the Minecraft server. We're going to spin everything up from scratch. For our last step, we're going to need two separate terminal windows to spin up two separate servers. We're going to spin up Minecraft Server A, which will bind to our host port 25,000. And we'll spin up Minecraft Server B, which will bind to our host port 26,000. Start up those two containers and let them run. Now, we need to edit our declarative configuration file. That's kong-minecraft.yml. Let's open that file up. And actually, we're going to delete everything underneath the format version, and we'll pretty much start over. First, we add an upstream object, which we're going to arbitrarily name Minecraft servers. The upstream object functions like a virtual host for load balancing to multiple services. We add two target objects to our upstream service. Each target has an address with host and port. In our case, our two targets point to localhost 25,000, that's Minecraft Server A, and localhost 26,000, that's Minecraft Server B. Then we set a weight for each target, which the load balancer uses to determine how to distribute the load. Next, we declare our service object, which in this case is our load balancer service. Requests that satisfy the routes we establish will be forwarded to the Minecraft server's host. That's our load balancing upstream object. So we use the name of that upstream as our host. The protocol for this service will be TCP. Similar to our previous step, we configure a route telling Kong Gateway to listen for TCP or TLS, requests destined for the IP address 127.0.0.1, that's our localhost IP address, on port 20,000. We save the file, and then we restart Kong. Now, let's test that Kong is properly load balancing requests to our two Minecraft servers. In our game client, we'll connect again to localhost 20,000. And we're in. And when we look at our server log, we see that the connection was made to Minecraft server B down at the bottom. We disconnect from the game, and we're going to try to connect again to localhost 20,000. And again, we're connected. And this time, when we look at our server logs, we see the connection was made to server A. So there we have it. Just by connecting to localhost 20,000, which is actually Kong's load balancer, our connection requests are being distributed across our two servers. And that wraps up our walkthrough, where we've demonstrated how to use Kong Gateway to handle load balancing and port forwarding of TCP streams from Minecraft game clients to two simultaneously running Minecraft servers. Thank you for joining us.